Hey everyone, welcome to day 6. So June 4th, day 6 of Math 133. We're still counting Memorial Day, even though we didn't have class that day. That was class 3. So we're counting this as day 6, even though we've been in class 5 times. So um yeah, so today we have a project and a chapter 3 review to go over today. So if you haven't finished the work from day 5, it's okay if you turn it in, before midnight tonight. Hopefully you've already submitted it. I'm going to try to catch up on grading this weekend. So if there's things in there that haven't gotten graded yet, and you're like, hey, I really need to know how to do this, or I really need to know how I have been doing, um, I'll get caught up. So. Um, all right. Today, um, we're gonna do the chapter 3 review. Just like we did with the chapter 2 review, we're gonna kind of work on it together. Remember that these worksheets these are a big deal. These are how you're gonna do well on the midterm, but these worksheets also make up 25% of your grade. So we will get to finish this worksheet tonight. But I'm not giving just the answers. We're gonna work on them together. I'll probably do 2 groups this time. We'll have some bigger groups. But that way Cindy and I don't have to jump back and forth between rooms. Not that that was really a problem, but um, and then the chapter 2 project is going to be very similar to other chapter 2 projects that we've done before. So again, I'll probably have you guys work on those together in groups. Okay. So that way, if I get kicked off of Zoom, you guys can just keep trucking. You can keep working on stuff. So. No, let's hope that doesn't happen again. All right. I have already posted the video for this morning. I actually was really good and got that in there. I try to get the recordings in there just as soon as I can. But let's start with the chapter 3 review worksheet. And you're going to find that on page 306 in your course pack. So you're going to want to get that out. It's 4 pages. So 306, 307, 308, 309. So go find your course pack, pull those out, get a pencil. Um, but in Canvas, I still do want to click on this worksheet because one of the data sets is in StatCrunch. So if I open up in Canvas the Chapter 3 worksheet review and click on this, it's going to bring me to StatCrunch. It's going to bring me straight to the data set. Oh, wait, nope, I got to sign in first. So once I've signed in, there we go. You're not going to have to go search for it. So if I just click on this link, so don't type in statcrunch.com. You'll want to actually click on the link because it's going to bring you here and you'll have all the data already in there ready to go. Okay. Um, all right. So I'm gonna pull up my visualizer. Let's do this. There we go. See if this will work. There we go. All right. So chapter 3 review worksheet. So question 1, the following data shows the ages of a random sample of business executives at a conference. So here's all my ages. Okay. There's a whole bunch of them. And I can find that same information in StatCrunch. So part A, we're going to calculate a whole bunch of things. Okay. So give 3 decimals if needed. Okay. Um, so X bar, that is the mean. Okay. And then P50, that's the 50th percentile. So if I was to break up all of my data into 100 different buckets. The 50th one is right in the middle, so that is my median. Okay. Or Q2, right? Q2 is quartile 2. If I break my data up into four groups, I have four quarters, four quartiles. The first one is the first quartile. The second one is right in the middle and splits the data in half and has a special name, and that's the median. So all of those mean the same thing. Um, Mode, that's the one that's the most. N is the sample size. Okay. S is the standard deviation. Okay. S squared is related to the standard deviation. It's called the variance. Variance. There we go. Did I spell it right? I get that. Minimum, maximum. If P50 is quartile 2, percentile number 25 splits my data into quarters, and it's the first quarter, so it is the first quartile. Same thing with 75. That is the third quartile. Range is the min minus the max. Interquartile range is Q3 minus Q1. Okay. So on page 232 in your course pack, we talk about some methods for calculating things. And method number one on page 232 allows is how to do this in StatCrunch. Okay, so we have our raw data column right here, and we have our raw data column over here in StatCrunch, and it tells you on page 232 what to click on. Page 232, by the way, in your course pack is yellow. It's the part of the exam notes packet. So we're going to start looking at this today, learning about what all of this stuff means so that on exam day, you'll be able to use this and answer questions. Okay. All right. So page 232, method number one will allow you to actually get all of this. Okay. Not just the mean, even though, the mean and the standard deviation is one of the things that it talks about on that method one on page 232. But you can get everything with this. So okay, so next, I'm not gonna do those. I'm gonna have you guys work on groups, have someone share your screen, share their screen, show everybody how to do it. But moving on, lower fence and upper fence, that was in our notes on page 84. Okay. On how to calculate those. So lower fence and upper fence are related to the quartiles, and they tell you if you have any outliers. So that's part D. Are there any outliers? You are really just checking if anything is past the fences. Okay. So if there's any outliers, and again, that's on page 84. Okay. In your course pack. What appears to be the shape of the distribution. I don't expect you to graph this, although StatCrunch can graph it. So, but on page 87, we talk about how to tell based on the mean, the median. Um, so, part F, what measures of central tendency and spread should we use? Also on page 87, we talk about that. Okay. There's three different measures of center, right? Mean, median, and mode. So which one should we use for this data set? And there's three measures of spread we've talked about: standard deviation, range, and interquartile range. So which one should we use there? I'm skipping variance. Variance is a measure of spread, but variance is not something that we generally are going to use often. Standard deviation is closely related to it, so and it's a little more useful. So, but range, interquartile range, and standard deviation is one of the answers for part F. But we need to know why you would pick those. Find the Z-score, part G, of an executive who is 41 years old. Is this unusual? So how do I tell if something's unusual? Uh, that you'll find on page 231. Now again, uh, page 231 is the yellow packet for the exam notes, okay? And it explains how you can tell if something is unusual or not, okay? All right. So I'm not giving you answers, but I'm giving you some big hints on where to find things for this review packet or for this review worksheet. Okay. So, all right, next page, we've got some box plots. All right. The box plot shows the payroll in salary for all the major sports teams in the US in 2019 by category. Okay. So, which sport had the highest average? So that we're just using the center line of the box. Okay. Center line of the box, which is actually a median. Generally, when we talk about average, we usually are talking about the mean, but we don't have means here, so we'll use the center line, and that's fine. Um, which sport had the smallest range? Range is max minus min. Okay. So these box plots here are what's called a 5-number summary. So the middle line is the median. Okay, I mentioned that a second ago. Uh, so this line on the left of the box is quartile 1. This one over here is quartile 3. Um, the end of the line right here is the minimum, and the end of this line over here is the maximum. So those 5 numbers, min, max, quartile 1, quartile 3, and median, actually break your data up into 1, 2, 3, 4 pieces. Okay. Um, so if you have stars like this, that means there's outliers. Okay. All right. Part C, which sport had the largest spread? So the spread is the interquartile range, which is Q3, which is this line here, minus Q1, which is this line here. So interquartile range is just the width of the box. Okay. That's the
I have a
interquartile range.
question.
Sure, absolutely. Go ahead.
What determines how big the whisker is going to be versus if it's an outlier or not?
Yeah, that's a good
Just
question.
if
So
it
the
mathematically is an outlier, then it would be the star.
Yeah, so we talked about fences a second ago on the previous page.
Hmm.
And um that's how you can tell if something is an outlier if it's past the fences. We talk about that on page 84. So the person making the box plot, it's their job to determine if anything's an outlier. So looking at this right here, we're saying that that and that are an outlier. Here's an outlier right here for hockey. Um, so otherwise, what would happen is if you didn't put that star there, you'd have this line right here like this. And that makes it look like there's data all along this line. And that's not true. Okay. There's a data point here, and there's maybe, a couple data points in here that are all grouped together. But notice how they're kind of close together. This star down here is way out there. Okay. So it's based on the fences. You don't need to calculate any fences here. Um, but yeah, just be aware of that.
Okay.
Um, okay, so for part D, what was the shape of the distribution of the hockey payrolls? You can find that on page 86 and 87, how to tell based on this 5-number summary. So, um, Don't forget units for these. Okay, so part G, explain using the graph which sport you think has the largest problems regarding disparity in team sports. So as a data analyst, my job is not just to look at my job is not just to create graphs and charts and do z-scores all day long. My job is to take a look at the numbers and explain what they're telling us and how we can fix that, right? So, as a statistician, we are trying to improve our business or wherever we're working. So, in this case, it's saying which sport do you think has the largest problem regarding disparity in team payrolls? Disparity means differences. So, which sport has the largest problem with huge differences between payrolls between teams? So I'll ask that to you guys. Which sport is it? Baseball, basketball, football, or hockey has the biggest differences? Baseball. Yep. Baseball is very wide, right? It has a huge range, it has a huge interquartile range. It's just, it's not grouped together, right? So in baseball, we have that the range is so large. So, so now I know what the range is. I can calculate that. That gives me math. That gives me numbers. But if I was explaining like why this was a problem to someone, I need to be able to explain it in layman's terms. So why is it a problem that the range is so large? Well, down here at the minimum, there's a team that is, giving their players like $60 million a year. There's another team up here that's paying, their players like $215 million. And the problem with that is if you have enough money, you can hire better players, right? So if your team is poor, so the problem is that uh, the range is so large that poor teams cannot compete with rich teams. Okay. Right, and that's the problem. Like you see the same teams in the World Series every year. So on the other hand, something like basketball, yeah, you've got a player down here that's only making 110. You got a player up here at the top that's making 130, 140. But if your team is poor, you can still afford some good players and, you can still be competitive. You can still win some games against rich teams. So anyway, there was a movie on that, so for baseball anyway. Okay. Part H, explain what the graph shows about the payrolls for the different sport, how the payrolls for the different sports compare to each other. So that was just looking at baseball by itself. So comparing all the sports together, so baseball is a very wide range. The thing that jumps out at me is, and you can put a different answer depending on what you think is happening with these, but the thing that jumps out to me is that hockey players make significantly less. Okay. I mean, so I don't know if that's a problem or not. It probably is, especially since hockey is a very expensive sport to play, but that's beside the point. So, okay. So I think that's good on that page. Um, let's take a look at the next page. So, uh, the next page is our project. So, um, following frequency distribution shows the number of athletes for all participating countries and territories 2016 Olympics. So this is my population. Okay. It's not a sample. Um, so I need to fill in these numbers, but I'm going to pause here. I'm going to jump back over to Canvas and I'm going to do our project. So tonight's project is Chapter 2, Project 7, and it's those numbers. So it's right here. And if I click on this, and then I'll open this link, it's going to bring me here. And then I'll click on this link because that's going to open my data set for me. So here it is. Okay. And so you can work on this together, fill in the class midpoints. A couple of people were struggling with the midpoint formula, so make sure everyone in your group, as you're working through this, knows how to do these formulas.
Okay, excuse me.
Total. Yeah, go ahead.
Yeah, so I tried to open that, but it says like view only, like I can't add the stuff in. I don't know how to
Yeah,
fix that.
that's right. You need to do file, make a copy. That's why
Well, I did
this is
make a copy, but it still didn't work.
oh,
I don't know why, but okay.
interesting.
I'll try it again.
Um, the reason it's read only or view only is because we don't want people changing this because then it changes it for everyone. So that's why you have to make the copy. So I am curious now if it works for me.
Make a copy.
You might have to change your folder that you're saving it in to My Drive. Okay.
Okay, I got it to work. Thank you.
Wonderful. All right.
The third time's a charm.
Nice. Okay, so once you fill in all those numbers, you can submit that project, and so you'll have that done. But there are some questions about that data. So uh, how many countries were there? What's the population? So population is all participating countries. So all the countries participating in the Olympics. Um, okay. So um, part D, what type of variable is the number of athletes? So each country sends a certain number of athletes to the Olympics. So maybe the US sends like 400, maybe Greece sent like 200, maybe like the Netherlands sent like 50. So the number of athletes sent, um, what type of variable is that? So qualitative is usually words. It can be numbers, but for qualitative, uh, the number of athletes is a number, okay? And it is a number that you can do math on. So if I asked like how many uh, how many countries did the US and Canada send, I could add those numbers together, okay? So math in that case makes sense. You can do a comparison and say, okay, Russia sent fewer athletes than China. Okay, so you can do that math. So that means it's quantitative. But there's two quantitatives here. There's discrete and continuous. Continuous means it can be any number in that range. So this class right here is 50 to 99. So any number in there includes decimals or fractions, okay? So in order for it to be continuous, you have to allow things like 68.5. Can you have 68.5 athletes? No, you can't have half an athlete, okay? Um, even in the Paralympics, that's a bad joke. So you can only send a whole number. Whole number means it has to be discrete, okay? So you can send 50, you can send 61, you can send, 99, but you can't send 99.8. Okay. So it's discrete. This one's no problem. This one's easy. You guys got those ones. How many countries means you are looking at frequency. Okay. What percent means you're looking at relative frequency. Okay. The modal class, that's the class with highest frequency. Okay. What's the shape of this distribution? So for that one, just use the graph. So don't forget to do a graph of your frequencies for your project. Okay. So for this one, you'll just use a graph. Just look at it. Okay. This last one's the tricky one. Find the mean and unadjusted standard deviation of this distribution. Okay. Then interpret their values in the context of the situation. Okay. So, we are doing mean and standard deviation on this first page, and we're doing it in StatCrunch. Okay. Well, and I said use method 1 for that. Okay. For this one, we don't have the raw data. We have the binned groups. We have the classes, the buckets, whatever you want to call these here. Okay. So to do this, we're going to need to go to page 232 and use method 2. Okay. So page 232 is again in the yellow packet. Method 2 is another way to get mean and standard deviation, but it's what you do when you don't have the raw data. It's what you do when you have a frequency distribution, okay, like a histogram or grouped or binned, okay. Once you've done that, that's just going to give you these two numbers, the mean and the standard deviation. You then need to interpret their values in the context of the situation. What that means is you're going to use the give or take script on page 231. Okay. So on page 231, you'll write out the sentence using give or take in that sentence, explaining your mean and your standard deviation and all of that. So, okay. All right, great. And one more page. I'm going to turn you loose on it. So, birth rate of babies in the US is normally distributed with a mean of 7 pounds, standard deviation of 0.83 pounds. Draw a reasonable picture. So your picture here, so this right here is your mean, okay? And you're going to write the number there. So in this case, it's 7.17, okay? And then here, you're going to have another number. Here, you're going to have another number. So you're going to write out 3 standard deviations, okay? And then I want to see the percents. So this percent, how much is the percent in this area, in this area, in this area, and then, there's going to be a percent here as well. So it's going to be some tiny number. And you do the exact same thing on the other side. So what's the percent here and here and here, okay? This, by the way, this normal distribution, this looks like a line chart. Actually, if you have, it's just a bunch of histogram bars. It's just that, you don't want to draw all of those. So that's why, we just draw it with a line chart like that. Okay, so should be able to, once you've got that, you should be able to do these, no problem. This one, part E, unusual. We mentioned unusual already. I'll mention it again. It's on page 231. And that's going to explain whether something is unusual or not. Okay. That's the end of number 4. So number 5 down here is not talking about the same chart. This number 5 down here is separate. So true or false, the mean is the score at the 50th percentile. No, that's not it. It's the median, right? False. The median is P50. Okay. 50th percentile is the median, not the mean. That was on page 83. That's the answer. So, the standard deviation of a data set cannot be negative. So, page 68. So, can standard deviation be negative? So, S is greater than or equal to 0, which means that, yeah, that's correct. Your standard deviation is never allowed to be negative. Okay. The reason why is because in the standard deviation calculation, you square the numbers. Okay. The standard deviation, you can think of it as the average distance away from the mean. So you have your mean, which is in the middle, and then you want to see how far away the numbers are away from the mean. So you calculate your deviations, and then the standard part is just doing an average of them. But you square them. So when you square a number, if you multiply it by itself. So if you take a positive number times itself, you get a positive number. If you take a negative number and you multiply it by itself, you get a positive number. Okay. So you're only ever going to get positive numbers. You can have a standard deviation of 0. The only way to do that is if all your numbers are exactly the same. Okay. So that doesn't happen. All right. So part C is on page 87. If the median is significantly smaller than the mean, the data set is negatively skewed. Okay. I'm going to leave that one for you guys. So don't forget it. I gave you the answers for the other two, but yeah. So okay. So that's all the hints I'm going to. I've given you no answers. Well, okay, I give you a couple answers here and there, but I gave you some big hints. So hopefully we can crush this now. So what I'm going to do is I'm going to stop the recording and I'm going to break us up into